Let's integrate sine squared x over the square root of 1 minus cosine x from pi thirds to pi over 2. What I'm going to do to approach this problem is rewrite the integrand. What I'm going to choose to do is multiply top and bottom of the integrand by the same thing, the square root of 1 plus cosine x. I'm sure there's any number of ways to do this problem. What's making me think to approach it this way is that 1 minus cosine on the bottom and under that square root. Because when I multiply these together, I'm going to get a 1 minus cosine squared, which is a sine squared, and I can take that square root easily. All right, so let's see what I really have here. I have sine squared x divided by the square root of 1 minus cosine squared x. Well, that's a sine squared x divided by the square root of a sine squared x, so a sine x. And I might be worried that that needs to be an absolute value, but with my bounds here, that's a nice happy first quadrant angle. So I don't have to worry about those absolute values because everything is positive in the first quadrant. I still have my 1 plus cosine x hanging out here, dx. Well, the sine parts simplify nicely to where I'm integrating pi thirds, from pi thirds to pi halves, of sine x times the square root of 1 plus cosine x. And I think what I want to do now is a substitution. All right, I have a sine x dx. Well, that's my opposite of du. So I'm just going to go and write that du in there, and that's a u to the 1/2. If I rewrite my bounds, everything's going to be in good shape, and I'll be ready to find an antiderivative. Plugging a pi thirds into this formula for u, well, the cosine of pi thirds is 1/2. 1 plus 1/2, I get a nice happy 3 over 2. Plug in a pi halves, and I'm just going to get out a 1. So what I could actually do at this point, if I wanted to, is use that minus sign to rewrite those bounds in the order I'd really prefer them to be in anyway. And so now I'm ready to find an antiderivative and evaluate. And I haven't left myself enough room to do that, so I'm just going to move this last integral over to another board and finish on there. So there's that last statement. And here's my antiderivative, and I need to evaluate from 1 to 3/2. So let's see, I have 2/3, and let's see, 3/2 to the 3/2 minus 1. So I still have that 2/3 hanging out front, but this is a 3/2 times a 3/2 times a 3/2 take a square root, so that's 3/2 times the square root of 3/2 minus 1. Distribute, and that's the square root of 3 over 2 minus 2/3. And there's our definite integral.